Yes. So today's video we are going to see chapter 7, that's nothing but integrals. Okay. So first of all, what is this integral or what is meant by integration? Integration is nothing but summation. Okay, it's nothing but summation. So you may think, how is that I say that integration is nothing but summation here? Suppose I have a real line here from A to B. If I want to sum up all the points within from A to B in this case, so it can be A1 plus A2 plus A3 plus etc up to B in this case actually. So it's not possible for me to sum up all the minute points in this case, or if the length of the interval is a little bit large. For example, it extends from minus infinity to plus infinity, and if I define a function e power x over it. So how will you find out the sum of this one here? So in that case, what I will do here is we have this integration. So generally you would have studied till now like this. Summation over minus infinity to infinity. Otherwise you will have written it as summation over A to B. So here in this lesson, if you see, this summation is changed to integration of minus infinity to infinity. So the summation only is changed to integration here. Integration over minus infinity to infinity. If it's a limit, otherwise if you see here, first I took the interval A to B, so here I can write it as integral over A to B, here f of x dx. Similarly here also, if you see here, we have it as f of x dx in this case. Okay, this only we call it as integration. Okay, so we have with limits and without limits also here. First I'll just give you the basic formula here. It's actually called as an antiderivative also. So here this integration, it is otherwise called the antiderivative. So what is meant by antiderivative? Antiderivative is nothing but the inverse of differentiation here. So here if you see, if you know the differentiation formulas thoroughly, here in this part it's easy for us to understand. What is integral of k dx here? It is equal to kx plus a constant. Similarly, integral of x power n is equal to x power n plus 1 divided by n plus 1 plus a constant. So you may think, why is that for everywhere we write this constant actually here? See here, when you find out the sum, there will be, okay, certain equations, there will be some left out, small values will be left out when you find the sum here. So those negligible values only you write it as plus c in this case. Okay. So here integral of sin x dx is equal to minus cos x plus c. Integral of cos x dx is equal to sin x plus c. Integral of secant squared x dx is equal to tan x plus c. By now you will be able to figure out what did you study actually here. Your differentiation of tan x is what? It is equal to secant squared x you had. So here we are finding the antiderivative is what? Integral of secant squared x is what? It is equal to tan x. Got it? Similarly, integral of cosecant squared x is equal to minus cot x plus c. Integral of secant x tan x, what is it equal to here? It is equal to secant x plus a constant. The next one is integral of e power x dx, that is equal to e power x plus a constant. Here again it's integral of 1 by x dx, which is equal to log x plus a constant you get. And here it is integral of 1 by 1 plus x squared. You know what is differentiation of tan inverse of x? What is differentiation of tan inverse of x? It is equal to 1 by 1 plus x squared, you know here. So the antiderivative is what? Integral of 1 by 1 plus x squared will give you what? Tan inverse of x. The same way it goes for integral of 1 by square root of 1 minus x squared. It is equal to sin inverse of x plus a constant. Here again it's integral of square root of 1 minus x squared dx, which is equal to minus cos inverse of x plus c. Because you know that what is your d by dx of cos inverse of x? That's nothing but equal to minus 1 by square root of 1 minus x squared here. So the inverse of it you have it. Okay. So these are the basic formulas which you'll have to remember for integration. Now here we'll move on to exercise 7.1. So here exercise 7.1, they've asked us to find out the antiderivative. That's nothing but by inspection here. Okay, so I'm not doing it by that method here. So straight away we'll just start with integration here, because that only is important in this case. So here find an antiderivative. That's nothing but the integrals. So the question given is integral of sin 2x. Here we do not have any chain rule or anything like that. So what you will do here is integral of sin 2x is equal to, you know what is integral of sin? What is that equal to here? It's minus cos 2x divided by, what is it here? The differentiation of this. What is the differentiation of that? It's nothing but 2 plus a constant. In very simple way, I can say that, what will I write here actually here in this case? The coefficient of x, whatever you have, you will have to divide it. Under differentiation, what did you do? You multiplied it. You remember, it was cos 2x into d by dx of 2x you would have written there. So there you multiplied, here you divided. That's all, nothing else. That's the only difference you have here. So again I'll repeat, it's integral of sine 2x. So integral of sine is equal to minus cos 2x you have here. So integral of sine is minus cos of 2x divided by the coefficient of x. That's nothing but 2 plus a constant. Is it clear? Yes. Now the next one here. This goes for not only for trigonometric, for logarithmic or algebraic or whatever it is, actually it's the same procedure. Okay. Integral of cos 3x. So what is integral of cos 3x equal to here? It is equal to, okay, so here integral of cos. What is integral of cos? It is sine 3x divided by the coefficient of x. What have you got here? It's nothing but 3 plus a constant. If you're finding it difficult, you just remember this like this. Sine of ax plus b dx is equal to, what is it equal to? Minus cos of ax plus b divided by a. This is the formula you have here. The same way it goes for cos also. That is the coefficient of x, you write it here. Got it? Now here the next one, integral of e power 2x. So you know what is integral of e power x. What is integral of e power x? It is equal to e power x plus a constant. This is what you have here. Same way, your integral of e power 2x dx, you will just write it as e power 2x itself, because integral of e power 2x is nothing but e power 2x divided by the coefficient of x. If it's 1, not a problem. What is the coefficient of x you have here? It's nothing but 2 divided by 2 plus a constant. Got it? Yes. Now here the fourth one, ax plus b the whole square. So what is integral of x power n? What have you got actually here? Your integral of x power n dx is equal to x power n plus 1 divided by n plus 1 plus a constant. This was the formula we had here. So using this formula, what will you have here? Integral of ax plus b the whole squared. So what is integral of ax plus b the whole squared equal to? Ax plus b the whole power n plus 1. What will you have here? 2 plus 1 divided by 2 plus 1, okay, into the coefficient of x. Actually, how you get the denominator is by differentiating it. Listen carefully. I am not integrating that actually. I am differentiating it. That, okay, divided by, what will you have here? Differentiation of ax plus b will be nothing but a. So I am just telling you in a shortcut way. You will have to just write the coefficient of x, and this is applicable only for linear functions. Okay, linear function is what? Within the whole squared, you must have the degree to be equal to 1. Suppose if I have it as ax squared plus b and all, it's not possible here. Okay, you cannot do it. Okay, only if it is linear, the whole squared or whole power n or whatever it is, this sort of integration is applicable. Okay. Now coming over to the fifth question here. Okay, it is sine 2x minus 4 e power 3x. So here I have written sine 2x minus 4 e power 3x dx is equal to, what is integral of sine 2x here? You know what is integral of sine? What is it? Minus cos 2x divided by the coefficient of x. That's nothing but 2 minus, what is the next one you get here? E power 3x you have here. What is integral of e power 3x here? It's e power 3x divided by 3. So you will have it as 4 e power 3x divided by 3 plus a constant. Okay, so here integration of e power x is what? E power x divided by the coefficient of x I have written here. That's nothing but equal to 3. Yes. Now the sixth question. Integral of 4 e power 3x plus 1 dx you have here. So integral of 4 e power 3x plus 1 dx, which is equal to, again, integral of e power 3x. What is integral of e power 3x here? 4 e power 3x divided by 3 plus, what is it actually here? You have got it as 1. What is integral of k dx here? Integral of k dx is nothing but equal to kx plus c. So what will I get here? It's 1 into x plus a constant. That is what you have here. Okay, you understood? Okay. The seventh one, integral of x squared into 1 minus 1 by x squared dx. So integral of x squared into 1 minus 1 by x squared dx. What will you do here? Actually, here I have written it here, the question again. Now we'll just multiply it. When I multiply it, it is x squared into 1 is what? X squared minus x squared into 1 by x squared. What will happen there? X squared into 1 by x squared you will get here. This gets cancelled. You are left with minus 1 dx. So what is that you have here? Integral of x squared minus 1 dx. Now I'll have to integrate x squared. So what is integral of x power n dx actually here? It is equal to x power n plus 1 divided by n plus 1. This is what you have here. So I'll have it as x cube by 3 minus integral of 1. So what is minus integral of 1? It's nothing but x plus a constant. Is it clear? Okay. Now the eighth one, integral of ax squared plus bx plus c dx here. So here it's integral of ax squared plus bx plus c dx. If you want, you can just write it like this. That's not needed here, but anyhow, if you want, you can just write it here. You have it as bx dx plus integral of c dx. That is, they're separating it. That's all. So here, what will you have here? It's a into, again use the same formula. What's the formula? Integral of x power n dx is equal to x power n plus 1 divided by n plus 1. So using that formula, I can write it as a x cube divided by 3 plus b into x power 2 by 2, because 1 plus 1, what will you get here? X squared divided by 2 plus this c is nothing but a constant. So when you integrate a constant with respect to that variable, you will have it as cx plus a constant. This constant is different. Don't confuse this and this here. Okay. Now here the ninth one. What's the ninth one you get? Integral of 2x squared plus e power x dx. So what is the integral of 2x squared plus e power x dx equal to 2x cube divided by 3 plus integral of e power x. What is integral of e power x? That's nothing but e power x plus a constant. Okay, so here this is what you have here. Integral of e power x plus a constant you get here. Yes. Now here the 10th one. What's the 10th one you get? Root x minus 1 by root x the whole square. So root x minus 1 by root x the whole square, keeping it as it is, it's not possible for me to integrate it because I don't have anything the whole squared, and I told you already there, if you, other than the linear one, if you have anything in between, it's not possible for me to integrate it straight away also. So what I'm going to do here is I'm going to expand it by using a minus b the whole square formula. So what will I get? A squared. What is a squared? Root x the whole squared minus 2ab. 2 root x into 1 by root x minus 1 by root x the whole square dx. So what is root x the whole square? That's nothing but x. Here if you see it gets cancelled, minus 2 minus 1 by x dx. Now we'll integrate it here. So how do I integrate it? Integral of x dx minus integral of 2 dx minus integral of, what will I get here? 1 by x dx. So what is integral of x here? X squared by 2 minus this one. When you integrate a constant, what will you get? Minus 2x minus, what is integral of 1 by x? That's nothing but minus log x plus a constant. The 11th one, integral of x cube plus 5x squared minus 4 divided by x squared dx. So here again, under this integration, we don't have the u by v rule or anything like that. We did in differentiation here. Okay, so that part and all, you please forget it here. So it's not possible for us to do it like that. So what I'm going to do here is, I've written the question again here. I'm going to split it. Okay, so split it as fractions here. X cube by x squared plus 5x squared divided by x squared. Next is what? Minus 4 divided by x squared. You understood? So if you have a rational function like this, this is how you'll have to proceed. Split it here. So here if you see it gets cancelled, you're left with integral of x. Here again your x squared and x squared gets cancelled. It's plus 5 minus, this goes to the numerator. So you can write it as minus 4x power minus 2 dx. Okay, it goes to the numerator. So you have it as x power minus 2. Now I can use the formula. What's the formula? It's easy for me to integrate it now, no? So what is the formula you have here? X integral of x power n dx is equal to, what will I get here? So here, if you want, I'll just write the formula here. Integral of x power n dx is equal to x power n plus 1 divided by n plus 1. So when I write it, what will you get? X squared by 2 plus 5 into x minus, what will you get here? 4 into x power minus 2 plus 1. What is x power minus 2 plus 1? It's x power minus 1 divided by minus 1 plus a constant. Is it clear? Here also I am just using the same formula only here. Now next step, what will you get? X squared by 2 plus 5x. Your minus and minus, it becomes plus. So you will have it as 4x plus a constant. Is it clear? It's very easy. We'll be using the same formulas repeatedly, but the only thing is, you will have to be careful how you split or how you simplify it. That's the only thing which you will have to be a little bit careful here. Okay. Now the 12th question. The 12th question is also a similar one. Only thing is it's x cube plus 3x plus 4 divided by root x dx. Okay. So here how do I write it here? X cube plus 3x plus 4 divided by root x dx, which is equal to x cube by root x plus 3x by root x plus 4 by root x dx. Okay, I'll have to simplify in such a manner that I must be able to apply any one of the formula. All these are just algebraic values here. So when I take algebraic, the only formula which is available here is this. Integral of x power n dx is equal to x power n plus 1 divided by n plus 1. So I'll have to simplify and bring it that far. So it is x cube, root x is nothing but x power half. When it goes to the numerator, it becomes x power minus half. Similarly, here you have got 3x. When it goes to the numerator, it is x power minus half. Here again, it's 4 into x power minus half. Okay, so here I'll just simplify it here. It is x power 3 minus 1 by 2. What is that? It's nothing but 5 by 2. Here it is 1 minus 1 by 2. What is that? It's nothing but 1 by 2. Here you will have it as 4x power minus 1 by 2 dx. Now integrate it. What will you get? X power 7 by 2 divided by 7 by 2. Okay, what formula again I'm using here? Integral of x power n dx is equal to x power n plus 1 divided by n plus 1. The same formula. Only thing is what you have it as 5 by 2 plus 1. What is 5 by 2 plus 1? It's 7 by 2 divided by 7 by 2 plus 3 into x power. What will you get here? 1 by 2 plus 1. What is it? It's x power 3 by 2 divided by 3 by 2 plus 4 into x power minus 1 by 2 plus 1. What is minus 1 by 2 plus 1? It's x power 1 by 2 divided by 1 by 2. So here if you see your 3 and 3 gets cancelled. Others they don't get cancelled here. This goes to the numerator. So it is 2x power 7 by 2 divided by 7 plus this goes again to the numerator. 2x power 3 by 2 plus again this goes to the numerator. So you are left with 8x power 1 by 2 plus a constant. Is it clear? Okay. So the 14th question, it's 1 minus x into root x dx. Okay. So again, unlike your differentiation, you don't have any product rule or anything like that. Okay. So here you will have to multiply here and then differentiate it. Sorry, integrate it. 1 minus x into root x. When you multiply it, you will have it as root x minus what will you get here? X into root x dx. This is what you have here. So what is your root x? If you want, I'll just write it here. This is nothing but x power half minus integral of, what is this actually? It's nothing but x power 1 by 2 you get here. When you multiply it, you will have it as x power 3 by 2 dx. This is what you have here. Got it? So what is x power 1 by 2 when you integrate it? It's nothing but x power 1 by 2 plus 1 divided by 1 by 2 plus 1. What is 1 by 2 plus 1? That's nothing but 3 by 2 divided by 3 by 2 minus x power 3 by 2 plus 1. That's nothing but x power 5 by 2 divided by 5 by 2 plus a constant. Now here again this goes to the numerator. 2x power 3 by 2 divided by 3 minus again this goes to the numerator 2x power 5 by 2 divided by 5 plus a constant. Okay, so here this is what you have here. Okay, now the 15th one is also a similar one. Okay, so it's root x into 3x squared plus 2x plus 3 dx. So what is that I'll have to do here? I'll have to multiply this irrational quantity here. So what will you get here? It is 3x squared into x power 1 by 2 plus 2x into x power 1 by 2 plus 3 into x power 1 by 2 dx. Okay. Now when you add this, the base is the same, so I can just add the powers here. 3x power 5 by 2 plus 2x power 3 by 2 plus 3x power 1 by 2 dx. Now integrate it. What will you get? Okay, so again what's the formula here? You have x power 5 by 2 plus 1 divided by 5 by 2 plus 1. So what is 5 by 2 plus 1? That's nothing but 7 by 2 divided by 7 by 2 plus 2 into x power. What will you get here? It is x power 3 by 2 plus 1 divided by 3 by 2 plus 1 you get here. So it's x power 5 by 2 divided by 5. Same way here again 3x power 3 by 2 divided by 3 by 2 plus a constant. So again 3 and 3 gets cancelled. This goes to the numerator. So it is 6x power 7 by 2 by 7. This again goes there. 4x power 5 by 2 divided by 5 plus 2x power 3 by 2 plus a constant. Okay. Now the 16th one. 2x minus 3 cos x plus e power x dx. So it's very simple. It's only a direct question here. You'll have to integrate it. What will you get? 2x squared by 2 minus integral of cos x is what? Sin x plus integral of e power x is what? E power x plus a constant. Of course, finally it gets cancelled and you're left with x squared minus 3 sin x plus e power x plus a constant. Yes, the 17th one, integral of 2x squared minus 3 sin x plus 5 root x. Okay, so if you want, again I'm telling you, you just split and write. If you think that you will confuse or anything like that, if you want, you can write it like this: minus 6 dx you will have here, plus what is the next one you get here? 5 into root of x dx. And then if you want, you can go to this step here, straight away to the integration part. So what is integral of 2x squared? It's nothing but 2x cubed by 3. That's nothing but x power 2 plus 1 divided by 2 plus 1 you get here. Integral of sin x. What is integral of sin x? Minus cos x. Already you have a minus sign here, so it's plus 3 cos x, plus here again it's nothing but x power half. Am I right? So when I integrate x power half, what will you get? X power 3 by 2 divided by 3 by 2 plus a constant. So what will you have? 2x cubed by 3 plus 3 cos x. This goes to the numerator. It's 10x power 3 by 2 by 3 plus a constant. Yes. Now the 18th question. So what's the 18th question you have? Till now, the 17th one we have seen algebraic, exponential, all type of questions we have seen here. 18, 19 and 20 are trigonometric quantities. Okay. So integral of secant x into secant x plus tan x. So we'll multiply and see what you get here. When you multiply, it's secant squared x plus secant x tan x dx. So you know what's the formula for integral of secant squared x. What is it equal to here? It is tan x. Similarly, what's the formula for integral of secant x tan x equal to? That is also equal to secant x. So what will I write here? It is secant tan x plus integral of secant x tan x is what? Secant x plus a constant. Okay. Now the 19th one, you have got it as integral of secant squared x by cosecant squared x. I already told you u by v formula and all, you don't have under integration here. So we'll just simplify first of all and then bring it to a known integral quantity here. Okay. So the secant squared, I can write it as 1 by cos squared. Cosecant squared or 1 by cosecant squared is nothing but sin squared. So you're left with sin squared by cos squared. That's nothing but tan squared x. But when you go through the integral formulas, you don't have integral of tan squared x, you don't have any formula. So just think of any known trigonometric identity where you can write actually here. So you all know that your 1 plus tan square theta is equal to secant square theta, you know here. So what is secant square theta minus 1? It is equal to tan square theta. So I can write this as secant squared x minus 1. What is integral of secant squared x? It's nothing but tan x minus integral of 1 is what? X plus a constant. Is it clear? Okay. So here this is what? Suppose if you are not able to integrate any trigonometric quantity there, so bring it to a known identity where you can integrate it and then integrate it. Is it clear? Is the last one, the 20th question, integral of 2 minus 3 sin x divided by cos squared x dx. So here again I'll just split it as 2 by cos squared x minus 3 sin x divided by cos squared x, because keeping it as it is, it's not possible for me to integrate it. 2 by cos squared. What is 1 by cos squared? That's nothing but secant squared. Now here you have it as sin x by cos squared. So that can be written as cos x into cos x. So what is 1 sin x by cos x? That's nothing but tan x. What is 1 by cos x? That's nothing but secant x. So what will you get? Integral of 2 secant squared x minus 3 secant x tan x. What is integral of secant square? That's nothing but equal to tan. What is integral of secant x tan x? Actually, that's nothing but secant x plus a constant. Is it clear? So this exercise 7.1, if you see here, it's nothing but the basic of integration. That is, before going on to the next method by substitution and all, you need to know how you generally integrate all types of functions. So only for that part we have this exercise 7.1. So just go through this, and if you want, you just take some extra problems on your own and you can try as a practice for integration.